Okay, so guys, in this video, we are going to do something special. We have studied successive differentiation and we have studied the chain rule. Now we are going to combine those two things. So we will have to use the chain rule and then we will have to take the differentiation two times because we have to find y2. So by y2, I mean dy square divided by dx square. Okay, so we have to take the derivative two times. Now we have the function y is equal to square root of 6x plus 1, and we know that y is on one side and x is on the other side, so we can use the chain rule as dy by dx, okay, is equal to dy by d third variable dot d third variable divided by dx. So our third variable would be u. Now we can actually make this thing 6x plus 1 our u, so it would be a composite function, so u would be equal to 6x plus 1. Now this y thing can also be written as y is equal to square root of u. Okay, so now we can officially apply the chain rule. We can also write the square root as 1 divided by 2, so let's use it. Y is equal to u power 1 by 2. And now first of all we will find the differential of y with respect to u. So dy by du is equal to d by du u square root, and then we will use the power rule. So this is my n right over here, so 1 divided by 2, then the function power minus 1 negative 1 by 2, and the derivative of u would be of course 1, because du by du would actually be equal to 1. So 1 divided by 2, we can write this thing u in the denominator because then it will be positive. And now we have u is actually equal to 6x plus 1, right? Now let's find du by dx. So du by dx is equal to d by dx 6x plus 1. So the derivative of 6x would be 6 and the derivative of 1 would be 0 because it is a constant. So du by dx is actually equal to 6. Now we know that the value of u is 6x plus 1. So we can put the value of u as 6x plus 1 square root. Now we can put these things into the chain rules. So dy by du is multiplied by du by dx is 6. These things will be cancelled and we are left with 3, because 6 divided by 2 is of course 3. So we have 3 divided by 6x plus 1 by 2. So this is the first derivative. Now let's find the second derivative, d square y dx square. So d by dx, 3 will be separated because it is a constant, and we are left with d by dx 6x plus 1 negative 1 by 2. So we can actually reciprocate it, so it will become negative. So we have 3. Now we will again use the power rule. This would be my n, so negative 1 by 2, then the function 6x plus 1 power minus 1. Now minus 1 divided by 2 minus 1 is, so we have negative 3 by 2, okay, and then the derivative of the function, you see. So we have 6x plus 1 and the derivative of 6x plus 1 was actually 6. 3 negative 1 by 2, 6x plus 1 negative 3 by 2, and then 6. So we have negative 3 by 2, and we can write this thing in the denominator, then it will become positive. So 6x plus 1 multiplied by 6. Now we can actually cancel this 6 by this 2 right over here, so we have again 3. So negative 3 times 3 gives us negative 9 divided by 6x plus 1 power 3 by 2. So this is the second derivative. Now let's try this function. So again we have to find dy by dx, and u will be my third variable. So this thing right over here will be considered as u. So we can write y is equal to u power 4. So first of all, we will find the derivative of y with respect to u, and then the derivative of u with respect to s, because u is actually x squared plus 5x. Okay, so first of all, dy by du, u power 4, and it's actually very simple, 4u power 3. Now the derivative of u with respect to x, and d by, let's just apply the differentials, d by dx, d by dx, d by dx. So du by dx will actually be equal to derivative of x squared would be 2x, derivative of 5x would be 5. Let's just put back the value of u, so we have x squared plus 5x power 3. Now let's put these things into the chain rule. So we have dy by du. So the derivative of y with respect to u was actually 4 x squared plus 5x power 3, and the derivative of u with respect to x was 2x plus 5. And now we can find the second derivative. So d square y, so 4 will be separated because it is a constant, 2x plus 5. So we will actually use the product rule. Let's just use the product rule. This is my fx, the first function, and this is my gx, the second function. So 4 will be separated and we will actually separate it with a bracket. So the first function as it is x squared plus 5x power 3, derivative of the second function, that is 2x plus 5. Then the second function as it is 2x plus 5, derivative of the first function x squared plus 5x power 3. Derivative of 2x plus 5 would be 2x. 2, sorry. And how was it actually possible? So derivative of 2x plus derivative of 5. Now the derivative of 2x would be 2, x will be cancelled and we are left with a 2, and the derivative of 5 will be 0 because it is a constant. Plus derivative of x squared plus 5x power 3. First of all, we will use the product rule, so 3 as it is. Then the function x squared plus 5x power minus 1, 3 minus 1 is 2, and then the derivative of the function right over here. So the derivative of x squared plus 5x would be 2x plus 5. We have done this thing before. So 4, 2, x squared plus 5x power 3 plus 3, 2x plus 5 is actually present 2 times. So let's just write it with a square, 2x plus 5 square, and x squared plus 5x squared. So let's just multiply this 4. So 4 multiplied by 2 is 8. 4 multiplied by 3 is 12. Okay, so this is the final derivative, the final second derivative of x squared plus 5x power 4. Now these questions were actually very simple for the cases of chain rule involving second successive differentiation, but in the future we will be solving questions like these.